Everyone, welcome back. And it's time to do a lab to create an hub and spoke topology using these three vnets. And objective for this lab is going to establish spoke to spoke connectivity without using vnet peering. We will be utilizing the existing lab topology. So you're going to create a VPN gateway, which is going to be the part of vnet 1. And then you are going to form peering to vNet 2 and vNet 3. And for testing purpose, we are going to ping resources. Those are part of the vNet 2 to resources, which is part of the vNet 3. Our exercise starts with deploying a virtual network gateway. If you do not find virtual network gateways on your home page, then you can search this resource from the search bar. Let's hit this icon, and now let's hit create virtual network gateway. Same as you need to mention the subscription as going to be the default one, and then I'm going to give it a name VPN gateway. That is going to be the part of Central India, and this time you need to choose one. If you have private connectivity, then this type is going to be the express route. However, we are going to choose a VPN gateway. VPN type, leave it to the default. It's going to be the route based. However, you have option to choose a policy based, and the policy based will be used when you are forming a IPsec tunnel and you need to define your encryption domains. So we will be utilizing route based, and then SQ type. That is all depends what kind of requirement you have, how much data you want to pass it over. So for that, you can refer to the official documentation, what kind of SQ it fits to your need. However, in the lab, I'm going to use it at default one. Generation 2, I will leave it at default one. This is going to be part of vNet 1. And now it is asking gateway subnet address range. If you recall it, I have specified this is going to have a spatial name and a range you need to provide. And this is a kind of scalable solution. You can go for minimum /27, but I will leave it at the default one, which is going to carve a range which is going to be the 1010 0.0/24. You have option, you can change it. So if we want to change it, we already utilized 1.0, 2.0, and now let's choose 4.0. That is also fine. Create public IP address. You can create it. VPN gateway PIP is going to be the standard availability zone. You have option. This is again a zonal deployment. You can choose your zone, and you can also choose zone redundant. It means if you're going to choose a zone redundant, it means it is you can operate these VPN gateways active mode or active passive mode. So that is option up to you. For the lab purpose, I'm just going to choose availability zone 1. Active it is going to be the disabled. BGP, we do not need BGP as of now. Let's review and create. Validation is passed, and while creating this resource, it is going to consume a lot of time. So I'm going to pause the video and we'll come back once the deployment is done. Now we can see the VPN gateway deployment has been completed and we are good to go to the resource. Let's verify for resource. The SKU type is going to be VPN gateway to AZ. This gateway type is VPN. It's a route base and it's a part of virtual network, which is vNet 1. And the public IP assigned to this VPN gateway is 4.240.72.221. Before we go ahead and create steps to perform the lab, we need to delete the peering what we had on existing VNets. So from VNet 1, we had two peerings, and those peerings are basically to VNet 1 and VNet 2. We need to delete both of them. One thing you can notice, since these peerings were non-transitive, so we see the gateway transited, disabled, disable. And in this lab, what we are going to do, this should be enabled. So let's try to delete it first. It's deleting peering for VNet 2 to 1. Might take less than a minute. And now we can see the pairing is deleted. Let's now try to delete pairing 1 to 3. Should take almost the same time. Now this pairing is also deleted. Now we'll go back to the VNet one, and from pairing section, we are going to create the pairing again. This time I want to name it VNet 1 to 2, and the pair is going to be 2 to 1, since this is a first pairing between VNet 1 to 2. Last time we had used option none, which is a default one. This time I'm going to use this virtual network gateway. VNet 2 is going to be the remote. And let's try to add pairing geo. And this time you can see on my screen the gateway transit is enabled. and that is needed when you are going to use spoke-to-spoke connectivity. Meanwhile, let's add one more pairing, which is going to be the vNet 1 to vNet 3. This side it is going to be 3 to 1. This time we are pairing with vNet 3, and let's add this pairing as well. We will hit the refresh until we see both are connected. Now we can see both are connected, so the pairing has been established successfully. Now we are going to do a testing. So the first command prompt, you can see this is the Windows machine with the IP address 10.10.2.4, and this is the Linux machine. We can see the IP address here as well. This is 10.22.4, and let's try to reach 10.10.2.4, and that seems to be working. So we have connectivity between vNet 1 and vNet 2. Similarly, let's try to ping this IP address. We have connectivity from vNet 3 to vNet 1 also. And now we are going to do a testing from spoke to spoke. That means I need to ping 10.20.2.4, and that doesn't seem to be working. And there is a reason why it is not working. So let's try to fix our lab, and we come back to this screen once we're done there. We talked about UDRs. I technically do not have any route, which we can verify if I go to my machine, which is Linux machine, go to the networking section, and we will go to effective routes. We do see I have global peering, and this global peering is for 10.10.0.0/16. And the IP range for vNet 3, or I would say for vNet 2, is 10.20.0.0. So this is its own vNet. This is remote, and we are missing spoke to spoke routing. So let's try to fix it, and we will fix it with the UDR. So I'm going to create a route table. That route table is going to be, we'll use same resource, and this time it is Central India. We will name it UDR, which is going to be for vNet 2. Let's hit create. We need to create one more UDR, which is going to be for vNet 3, and that was East US. And whatever the UDRs we are creating, they should be attached to those vNets. How do we attach it? We need to attach those two subnets. Those are part of the vNet. So let's try to attach it. In between, let's verify the IP address again. So the IP address I have here on vNet 2 is 10.22.4. If I go to vNet 2, my subnet 2.0, which is public, and I'm going to call a routing table, which is going to be UDR vNet 2. Let's save it. Similarly, I'm going to vNet 3, and here the IP address is 2.4, that is again the public. Let's attach UDR3. Now we need to add a route table to those UDRs. Let's add the route inside those UDRs. So first we will take a look on UDR, which is part of the vNet 2. And this UDR, you need to add a route. So I'm going to add a route to vNet 3 IP, and vNet 3 is 30.0/0/16. Next hop type is going to be the virtual appliance, and we need to put the IP address for virtual appliance. If you take a look on this, the gateway subnet what we had is 10.10.4.0. That means the VM which is meant to run a gateway will get the first IP address. So we need to put an entry which is going to be 10.10.4.4. And let's add that. I will copy this. So it is needed to add another route from vNet 3. I go back to UDR and add a route here, this time to vNet 2 IP space is 10.20.0.0/16. Next hop type virtual appliance. Gateway is going to be same. This is successfully added here, and let's go back to and do our testing. So the first testing we need to perform whether we have a reachability to IP address, which is a private IP address for VPN gateway, and it doesn't ping. Similarly, it won't ping because ICMP has been restricted here. So let's do a ping directly to a machine which is part of vNet 2. And this time we see it is successfully able to respond to the ping request. That was it for this lab. Thank you for watching, and I will see you in the next section.